Yes, hi. This is Marcus Bianchi. We have a Better Buildings Alliance call or webinar today. This is the space conditioning technology team. Many of you may know that. Next slide, please. So this is the agenda. The team itself, it's myself, Marcus, Greg Shukas, who is also one of the speakers, is going to talk about the AFDD findings that we have, which is the topic of the call today. And Michael DeRue, who is actually, it's also at NREL. I don't know why the NREL got lost. But the three of us are working with the Better Buildings Alliance space conditioning team. Today we have a webinar on automated fault detection and diagnostics. The perspective is to give an overview first of the work that we have done this year on analyzing some of the results from automated fault detection and diagnostics, and Greg will briefly talk about some of those findings, followed by users. So LBA Realty and Ulta, Michelle German and Megan Runnion, both of them will talk about the perspective now, not so much on the technology and the technical side, but what is the perspective of different users of automated fault detection and diagnostics, and then we'll have a discussion. Next, please. Just to remind you, I don't want to spend a lot of time today on the space conditioning team, but I want to tell you that some of those resources can be found in the HVAC resource map. The address is on the screen, and there are many resources for HVAC there. Next slide, please. So Greg will take from here. Greg.
Thanks, Marcus, for the introduction. My name is Greg Shukas. I work for the National Renewable Energy Lab, and I wanted to present to you on our recently published technical report for the BBA titled Analysis of Fault Data Collected from Automated Fault Detection and Diagnostic Products for Packaged Rooftop Units. Next slide, please. So we're aware that automated fault detection and diagnostics is a powerful tool that can monitor the health of HVAC equipment and inform building owners when anomalous behavior and off performance is happening to give them a heads up to address an issue. Leading up to this effort, there have been no large-scale studies on the installed performance of these systems. So our objectives were to acquire data sets from building owners that use these systems and analyze that raw data to gain a better understanding of how these systems operate, the types of faults, the frequencies of faults that are identified by the systems, and how the building operators interact with these systems. So while we came up with some conclusions related to these objectives, as we got into the analysis, it forced us to think about other items. And in the full report, which I hope you will read, we came up with recommendations that would help to bolster the quality of the raw data so that in a retroactive analysis scenario, the data is a lot more clear, easy to understand, and useful. Next slide, please. So the top table shows the data sets that we were able to achieve, or able to acquire rather. There were 5 raw data sets provided by 3 companies. We'll call them company A, B, and C, shown in yellow, blue, and green. And NREL analyzed this raw data. The data spanned anywhere between 1 week, more like 9 months to a year. And the data was in different formats. So we had to do a lot of slicing and dicing to analyze this information. We were able to acquire a summarized set of AFDD data from a fourth company. We'll call them Company D. And they have pulled from 6 years of their archives to provide this analysis for us. In the center table, we see the faults or the fault categories that each of these companies reported faults to. So these fault categories are binned into cooling, heating, economizing damper, air side of the system, sensors, communication, power phase, and other. And for our 4 companies, we see differences in the different fault categories that they report to. So while we can't do an exact direct comparison, there was a lot of overlap in which we were able to do a good comparison. Interestingly, Company B and C provided AFDD systems to the same small box retail chain. And interestingly, they report in different categories as well. This was our best opportunity to do an apples to apples comparison, despite the fact that Company C only provided 1 week of data and Company B provided 12 months of data. The bottom table shows the architecture of these systems. Company A has a retro controller type system that they use to detect and diagnose faults. Company B, C, and D all communicate with the BMS. In addition, Company D communicates with the control board of the RTU in order to extract error codes. Next slide, please. So starting with Company A, they provided in all 3 of their data sets detailed information about every RTU monitored. And for every RTU, there was a daily summary for the various faults they could detect. And in that daily summary, it showed how many hours a RTU may have experienced a fault condition. These faults are communicated to the building owners via email. And what we found through all 3 of the data sets is that overwhelmingly for Company A, they were reporting significant numbers of economizing damper faults. They reported very few sensor faults and very few communication faults. When we dug deeper into these economizer faults, what we found is that these economizer faults were persistent. In the plot to the right, we see the number of consecutive days, 24 hours per day, of economizer fault for 9 out of the 15 RTUs. So what we learned is that there were a percentage or a group of, say, bad apples that were contributing and skewing this economizer fault frequency data. Next slide, please. The next sets of data that we analyzed were for Company B and C. Both of these companies provided AFDD services to, or systems rather, to the same small box retailer. There were differences in the raw data sets. And when we analyzed the data, we found consistency that they were both reporting around 50% sensor faults, unlike Company A, which presented almost or reported almost 0 sensor faults. Second to sensor faults for Company B were communication faults, and second to sensor faults for Company C were power demand and phase faults. It was curious that there were so many sensor faults when analyzing Company B's data, but Company C provided a little bit of insight with additional details in their raw data set that allowed us to understand why this fault category was binned so frequently. What we found is that sensor faults reported by Company B and C were out of range sensors. So if a set point were, for example, 72 degrees, and the sensor measured an out of range value, say 74 degrees, the companies were binning this as a sensor fault. Other companies might interpret that as a cooling fault or a heating fault, where the system is not able to reach set point. However, company B and C interpreted that as a sensor fault, and that's where we get this very large 50% slice of the pie. Next slide, please. The last data set from company D was analyzed for us from their 6 years of data. They were provided with respect to fault categories, climate zones, and RTU age. Now, of all the data sets we got, RTU age was unique to this data set and a very powerful piece of information. It's unknown the number of RTUs with and without economizers, but what they presented in the upper right-hand plot is that cooling faults were the most frequently identified faults. Unlike company A, B, and C, economizer faults and sensor faults were the least seen faults in their archived data. This company is also able to communicate with the RTU control board, which is able to provide a level of fidelity at the equipment level that working at the BMS level or a retro controller architecture is not. They are able to directly pull fault codes from the OEM equipment and pull out more accurate and more pointed error codes associated with the RTUs. Next slide, please. So in summary, these are just a few conclusions that have been pulled from the report. I encourage you to go to the report and in addition, look at the recommendations that we also included. But we found that high fault frequencies can be associated with a small number of problematic units. And comparisons between AFDD companies is difficult. It's not as straightforward as what we thought and set out to do. The types of frequencies of the reported faults depends on diversity in the number of points monitored, in large, the interpretation of a fault's definition and the category that they're putting that fault into, the diagnostics approach and the architecture of the system. The systems that can communicate with the RTU control boards are able to leverage the existing onboard fault diagnostics at the equipment level. It can characterize the equipment faults more specifically and accurately and identify the problematic units that may justify early replacement. So having a good set of clean, accurate data that tells a full story, and some of those recommendations can be found in the report, are important for archiving data for post-processing and looking back to do more thorough analyses. There's a link at the bottom of this slide where you can find the report. And with that, I can conclude this presentation. Next slide. If there are any questions associated with this study, please reach out to me. My contact information is on this slide. And I'd like to thank Marcus Bianchi and Michael Deroux for participating and supporting this work. Thank you.
Hi, this is Michelle German. So I'm going to talk a little bit about LBA's Smart Building Program. So before I get started, I just wanted to give an introduction to myself. I'm the Director of Operations and Sustainability for LBA. We're headquartered in Irvine, California at our corporate office. And so I work in the corporate operations group, assisting with overseeing all of our operations and driving our sustainability program. So I've been with the company almost 10 years now, and I'm excited to share a little bit about LBA and our program. So next slide, please. So LBA, we're a full service real estate investment and management company. So we have about 65 million square feet of both office and industrial properties across the nation. Our product type right now is about 80% industrial and about 20% office. So LBA has a strong focus in sustainability, and we focus our efforts in what we like to call our sensible sustainability strategy. So not only do we focus on the environmental outcomes and making sure we're doing the right thing with regards to that, we also need to make sure that there's a business case in all of these projects that we're focusing on. And so we have KPIs and goals that we set each year, and really our main focuses are around energy, water and waste efficiencies, renewable energy, clean tech, health and wellness, and innovative technology. So what I'm going to kind of cover today falls in the category of innovative technologies and the energy efficiency category. So we also have a 10-year commitment with the Department of Energy's Better Building Challenge to improve our energy intensity of the portfolio by at least 20%. And so we're currently on track to achieve that goal with an annual percentage improvement of 3.9% each year. And so our results through the end of 2019 was 3.06% in energy reduction across the portfolio. So just want to share a little bit about the company so you have some context about our smart building program that I'm going to talk about today. So next slide, please. So today I just want to share a little bit about the steps that LBA took to decide on a smart building program for our office portfolio with Yardy Energy, and so and how we implemented it, our results to date, and where we're projecting 2021 results to look like. So what was our smart building program approach? It started with what we like to call our pilot program. So we had a large, sophisticated office campus called Park Place in Irvine. That's actually where our corporate office is located out of. And it was a top performer building. It had LEED and Energy Star certifications, and we had always, done a lot of work there. But we just wanted to test the concept of an enhanced smart building solution, just to further enhance performance from an environmental and a financial standpoint at this property. So when we initially rolled this out, the Yardy Pulse platform at this project, we didn't actually know at that time that this would be considered our pilot program, because ultimately the proven success of that project is what got our wheels turning and the conversations with Yardy going on, how can we bring this concept to our entire portfolio. And so just wanted to share some of the thought process and why we selected Yardy other than the proven success at our pilot property. So we were able to come to terms with Yardy where LBA didn't have to have any upfront costs. So there was no capital outlay to us in this project. And so since this was going to be a portfolio solution, we just wanted to think through that scenario. And a big part of that was because we are always at different stages in our hold periods. LBA's kind of hold periods about 5 to 7 years. And as a result of that, we're, buying and selling constantly. So we wanted a solution that would work in that model. We also wanted to have a unified platform across our portfolio. So, one system we go to, understand how it works, be able to roll up results easily, plug and play when we buy a new property. And so that was a big part of our decision. And that another reason, or another big thing, was that the solution integrated well into our existing systems at the property. And so this platform did that. We also, our engineering team and our service providers were part of that process up front of vetting all the options with the platform we wanted to roll out with. And also because of the proven success at Park Place, we were able to get buy-in early from our stakeholders. And so our last point is that we were just really interested in innovation and whether we can turn targeted buildings into smart buildings. And so that was that innovation piece that I talked about as our goals. And so next slide, please. So I wanted to share what the implementation looked like and kind of how we broke it out. And so first, as I touched on a little bit, there was a big team effort involved between the engineering team, who really are the technical experts of the building, the Yardy consulting team, who are the energy experts, and then our operations team, who really helps to orchestrate it all. And then, the operations team rolls under me. And so, I really rely, I run it from, more of the operational rollout standpoint, but I really rely heavily on my engineering group from a technical perspective. And so all of that together, we had really good engagement. And again, I think that was largely in part to the successful rollout at Park Place, and then just involving the engineers up front made them feel really involved. And so what we found in prior platforms is that, you can do a fault detection and diagnostics platform, but if you don't have, a good process in place, you don't have your engineering teams engaged, involved, and bought into it, it just becomes wallpaper. And really, there's no actionable items that take place if the engineer is not looking at these, fault detections, and they're not looking at the data. And so the way that we position this all between LBA and Yardy and our engineering team is that, the engineers get the fault detections, and Yardy also plays a role in reaching out to the engineer and actively working together on making those items actionable. And so initially, the first few months of going live is really to make adjustments to kind of the operations, or the building operations of the building. So I kind of jumped ahead a little bit. I just wanted to just pause for a second just to go in the right order here. So we really rolled this out in a crawl, walk, run approach. So I was already jumping into phase one, but I didn't mention to you guys that phase one is where we implement the real-time metering and the fault detection diagnostics. And so during that process is where we're able to really gain insight into the building and make operational adjustments that improve the way the building is operated. So think of, shifting the run times, HVAC diagnostics, and things of that nature. And so that's what I was just kind of mentioning a minute ago. During that phase, the engineers aren't just getting alerts and seeing wallpaper, they're actually actively working with the Yardy consultant to make those adjustments. So the first few months are a lot heavier, I think, figuring out like building start times and making sure everything looks good. But as I would imagine you all know, things can happen at the building level at any time throughout the life of the building. And so that fault detection diagnostics is a continuous process that we stay in phase one for the duration of having the Yardy platform. So then next, after phase one, and we're able to do those diagnostics and get up to speed on the building, we said to, or Yardy and us came up to the agreement that then we would roll into what we call phase two, which is the active energy efficiency phase. And so during this phase is where the smart building program really comes to life, because they're utilizing energy automation and artificial intelligence at that time. And so during that phase of setup, the Yardy team is really working in close collaboration with our engineering team as they establish those set points and make sure the engineering team feels comfortable with it, make sure that we're not sacrificing tenant comfort in any way during that setup. And so once that phase goes live, the platform is continuously learning the building, and then they're actively making, very minor adjustments, which ultimately runs the HVAC system as efficiently as possible. And, therefore we see some really good energy savings, both on consumption and on cost. So I also just wanted to share some visuals of the dashboard. So next slide, please. So this first one is our operations dashboard. So this is more of a view that a property manager would see, or someone like me on the corporate operations side. So a little bit more user-friendly, more visual, less technical. And if you go to the next slide, you'll see that this is more of the engineering dashboard. So it's a little bit more, or a lot more technical. Like I said, I'm not the technical person. So for me, this isn't where I would go to understand what's happening in the platform, but definitely this is where our engineering group goes. So next slide, please. So just wanted to share some of the highlights of this program to date. So we initially rolled out in January of 2019, not with the Park Place program that happened prior to, but with the remainder of our portfolio. So since that date of January 2019, we have contracted for 11 office buildings totaling 5.9 million square feet. And so the pulse metering analytics and fault detection, or what we call phase 1, is currently live at 8 of our properties. And the pulse building optimization, or phase 3, has been implemented at 3 of our properties. So the program results from January 2019 through September 2020 has been a consumption savings of 20.4 million kWh and a cost savings of approximately 2.5 million. So that's across the portfolio so far. So next slide, please. So just wanted to share, what's next. We still have that 1.3 million additional square feet to onboard for the remainder of the year. And in addition, as we acquire new office assets, it's built into our process to vet this smart building program through the acquisition process to determine if our property, if that specific property is a good candidate. And if it is, then we would be adding it to our master contract with Yardy at the close or at acquisition. So if we meet all of our targets that I've talked about by year end, our projected 2021 savings for the year would be a 15.3 million kilowatt hour of consumption savings and approximately 1.9 million in cost savings. So with that, that's kind of a snapshot of the LBA Smart Building Program and how we're utilizing it across the portfolio. And we look forward to continuing to add more properties and seeing some good energy savings over the next several years. So with that, thank you for listening to my presentation.
Thanks, Michelle. My name is Megan Runnion. I am a project manager within the energy and sustainability team at Ulta Beauty. I'm going to discuss a little bit about how we use fault detection data in our day-to-day building management across our portfolio. Next slide. So a little bit of background on the Ulta Beauty portfolio. We've got over 1,200 stores throughout the United States and over 5,000 RTUs total. We've got a mix of system types and manufacturers, though a typical store setup, a standard store is about 10,000 square feet. We typically have 4 RTUs totaling about 40 tons of cooling capacity. We also do have energy management systems in all of our stores. Really the 2 main energy consuming systems that we're looking at are lighting and HVAC in our stores. We do have a little bit of domestic hot water usage in our salons, but the real bulk of things is lighting and HVAC that we're focusing on. In terms of priorities within our team and for Ulta Beauty overall, store comfort is a huge one. When guests come into our stores, we want to make sure that they have a positive shopping experience. We do have salons in our stores, so it's really important that when someone's coming in for a makeup application or a hair service, that the store is at a comfortable temperature and that it's well lit. But of course, energy savings are a huge driver as well, especially for myself within the energy and sustainability team. So always keeping that in mind and trying to balance those 2 priorities. Goals in terms of AFDD, we're looking to proactively identify, troubleshoot, and resolve issues at our stores. Having over 1,200 stores and just a small corporate team to manage energy, we don't have a ton of internal resources to manage those issues. And being that our stores are only 10,000 square feet, when we do have issues on site with an HVAC unit or with lighting, it impacts the store significantly and pretty quickly. If we've got an HVAC unit go down, we usually can't have a hard time making it up with the other units. and it's something that needs to be addressed sooner rather than later. And so trying to be as proactive as we can in preventing issues or resolving issues as they come up, as opposed to being reactive and having the store sit in an uncomfortable position for an extended period of time while we're trying to address the problem. We also want to monitor and track our store conditions as well as individual unit performance and the maintenance needs of the store. Next slide. So this is just a snapshot of some alarms that we receive. So we do have alarms that are automatically generated based on criteria through our energy management system. And this is just a moment in time. You can see that just at this moment, this is a screenshot I took in the afternoon one day, we had 297 active alarms at that time. So as you can imagine, I'm only one person. There's no way I'd be able to handle all of these alarms. I'd be completely inundated. So what we do is we utilize EMS monitoring vendors to manage alarms on our behalf. And so they'll prioritize critical alarms versus non-critical. You know, is it something that's immediately impacting the store environment, or is it having a significant impact on energy consumption in the short term, versus something that may be non-critical, maybe an ancillary sensor that doesn't control anything, that's just for monitoring purposes, is in fault. You know, that may not be as high of a priority. So we can prioritize issues that need to be addressed quickly. Those vendors will troubleshoot and resolve issues remotely where possible, which is great because we can try to reduce truck rolls when items can be addressed remotely or perhaps tabled for future PM or when a tech is going to be on site for another issue. And we don't have to necessarily roll a truck every time something comes up. But those vendors will dispatch as needed through our work order platform to get a tech on site for those critical issues that need to be addressed quickly. Next slide, please. Just a few examples of some of the alarms that we'll see. Zone temperature limits, so if the store is not maintaining the set points, and those are of course critical. We want to make sure we keep the store comfortable. We also get unit errors specifically to the HVAC units. And where we have Lennox units, this is especially useful because we can get the Prodigy error codes directly from those units. And then there's useful tools from Lennox, like their application, that can provide further descriptions of the issue, troubleshooting suggestions. We can provide more information to our HVAC techs when we're sending them out, get a better idea of what the issue is with the unit without even being on site. So that's really valuable. Sensors as well, including CO2 sensors, humidity, temperature, indoor and outdoor. Network health alarms, we can understand if any of the systems that we're monitoring and controlling are not communicating with our energy management system. So we can understand if there's large communication loss, if it's isolated, how much of the system is being impacted. Performance alerts is another one, and this is great for informing energy consumption. We can see how units are performing, if they're cooling or heating poorly or well. You can also see overrides, both remotely and at the store level. Any breaker issues, we've got Square D lighting at a lot of stores. We can see if there's breakers that are being overridden, and that's another big way we can drive energy savings. And then we also do have demand meters at our stores, and we'll be alerted through the alarm management system if any of those meters are reading improperly. Next slide, please. Some more advanced ways we're using this data and where we're moving towards, I think, in our energy management strategy. Things like fan cycle, looking at extended fan run times, lighting status, again, looking at stores where we've got extended lighting run times, longer than expected, so we can dig into those issues. Economizers, so either if units are economizing when they shouldn't be, or the opposite, conditions are optimal for economization and the units are not economizing. so we can dig into that deeper. And that's a big one for energy savings, but also store comfort as well. And then unoccupied KW, identifying stores where we've got high usage overnight. That's a big one, to be able to identify outliers with high usage and drive additional energy savings. And a big benefit here is that we don't have to wait for utility bills to identify outliers. We can get that data in the short term and address the issues quickly before, a month or more has gone by. Next slide, please. Something that we're moving towards that I'm excited about is using the data that's collected to really evaluate our HVAC units, both condition and to also be able to prioritize proactive replacement. So I do manage the HVAC proactive replacement program at Ulta. And historically, the way that we have identified units for replacement is, how old is the unit? So when a unit hits 13 years old, it gets put on the list for review. And then we take a look at the condition. So we actually get somebody on site to do a survey of the units and provide feedback on what type of condition they're in. And that's been useful for us. We've been able to have a great proactive replacement program. But what we're looking to do now, which I'm calling the better way, is to be a lot more data-driven in how we prioritize these units. Especially as kind of the list of units that are 13 years or older is growing as the years go by. I need a better way to be able to prioritize replacements in case I don't have the budget to replace all of them, or we may have to phase them out. So we're pulling in additional data, things like a comfort scorecard. So not only is the unit perhaps being rated as not in great condition, but the store environment's being impacted. It's not maintaining zone temp, there's humidity issues. If it's not being able to maintain that comfortable environment, it can get flagged. Fault scorecard, so seeing any issues that were identified in the unit over the course of the last year. HVAC runtime, unit performance, looking at the delta T. We can also pull in data from our work order management system to look at how many store complaints are we getting, or how many times did we have to dispatch a technician to the store, as well as what was the expense related to those repairs. And then pulling in energy data as well. Is the store's EUI being impacted? Are we seeing high usage at some of these stores that may be related to some of these things because the units are not running efficiently? And so therefore we can expect a better ROI by replacing those units. Next slide. And that's everything. Thank you.
Well, I think we got to the end of the presentations, and we should probably address the questions that we got. Did we get questions in the chat box, Nina?
Yes, there is one question. For Ulta site and really everyone, how do you modify under COVID-19? Megan, if you want to take that on, and Marcus, I'll go ahead and make you an organizer.
Okay.
Sure. So actually, some of the advantages we've had in terms of having access to this data and having our energy management systems in place during COVID is we actually ended up shutting down all of our stores, closing them in March for an extended period of time. And so while being remote, I had the ability to monitor what was going on at the store level, identify stores where we had HVAC or lighting coming on, even though the store was closed, or where we may have had HVAC issues, especially as we got into the summer months. And it was particularly warm in some areas, and we still had stores closed. Instead of sending somebody to a store to just do a wellness check and make sure everything looked okay, I could keep an eye on the HVAC operation, make sure humidity levels weren't getting too high, make sure that they were maintaining at least a reasonable temperature in the stores. and that things were going okay. So that was a big advantage of having this data available while stores were closed. As things progress and we're kind of adjusting and stores have reopened, but our team has still been impacted. Some of our budgets have been impacted, and as a project manager, I've had to adjust some priorities. And so especially with our proactive replacement program, we've been trying to limit spending as much as possible. So I was able to really narrow down my list of replacements for this year based on which units really needed to be prioritized for replacements. And so pulling in that data based on how are the units performing, where are stores having issues, this has been really helpful as we adjust projects based on updated budgets and perhaps move things to 2021 when we're hoping for a bit more stability.
Would you add anything, Michelle, maybe from your perspective?
Yeah, so it's just, ours is a little different story because, I'm talking about office properties. So we've stayed open the entire time, and we've had to, start our buildings. And so we're operating, I would say for the most part as is. Obviously the, occupancy is down, and so the load is not as great, but the central plant's up and running. It has been since the beginning, and we've also had to adjust the way that we're running the buildings, letting more of the outside air coming in and flushing the building a couple hours before and at the end of the day, just due to best practices having to do with COVID-19. So we've made adjustments, but I would say Megan's definitely able to do a lot more, and the data is helping her a lot more. In the COVID situation for us, it's kind of been the same.
Great. Yeah, it's a challenge, in some areas and not so much in others, I suppose. Just to remind the audience, we do have a couple webinars from last May to discuss a little bit of that about HVAC and not necessarily just COVID, but infectious diseases, and then unoccupied buildings, how to occupy again, if that's the case. I really enjoy the presentations. I'm trying to see if there are other questions from the audience. I don't find any at this point. So just to let you know that I'm open. Well, I guess we are all open to hear more. New topics, new challenges. We will be providing new project results in the future, and we're working now with two possible webinars. One on revisiting the Bill Benfleff talk on HVAC and infectious diseases, since we actually think that things probably have changed in 7 months. There's more knowledge about some of that, so it's an idea to work on that. And there is another one that people ask about, addressing specifically on the hospitality industry, how they are dealing with HVAC issues and COVID and so on. So we may be working on those. That being said, thank you so much for attending. This will be available through a recording, so many of you are listening to this and watching this as a recording. And if you have questions, please contact us in the Better Buildings Alliance website and at NREL. So thank you to the speakers for presenting and accepting to help us to talk about those topics. And with that, I think we close the webinar. Thank you.